Welcome back. In the last couple of videos, we walked through the Mint projects, covering how to download the data, to building a binary classifier, and measure the accuracy of our classifier using cross-validation, including certified K4. And we also look at performance measure using confusion matrix, precision, recall, as well as F1 score. And in this session, we're going to move into the precision as well as recall trade-off. Upfront, I just want to tell you that when you try to increase precision, it will reduce recall and vice versa. It pays to remember the concepts that we are talking about here. Precision is how accurate is your classifier in predicting positive predictions. Okay? So precision measures the accuracy of positive predictions. Recall, on the other hand, it measures the rate of positive instances that are correctly detected by the classifier. So we are talking about here, increasing one will be at the expense of the other. So let's just understand how this works. Again, I've done this a bit earlier. Okay, just to help you to grasp this concept. Let's just say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 observations here. Okay, so now if you look at this, what you have is the so-called predictions by your classifier. Now let's just take this middle one to begin with. If your classifier predict this point forward, that 0 being 0, so meaning it actually correctly classify 0 as 0, it will pick up 1, 2, 3, 4. 4 zeros here. Okay, it would have ignored these other two. So out of the 5 observations from this line onwards, okay, it actually managed to catch or positively predict 4 of them as being 0. So which is 4 out of 5. That means we have a precision of 80%. Let me reiterate again. What is precision? Precision is the accuracy of our positive predictions. So it is highly accurate. In this case, we have out of 5, 4 is indeed 0. What about the corresponding recall? Recall meaning out of all of the so-called positive instances, out of all the 0, how many was your classifier able to pick those up? So all in all, we have 1, 2, 3, 4, 5, 6 zeros. This predictor, when it actually predict from this point onward, or have this as the landmark, they only managed to pick up 4 out of the 6, which is 67% recall. Now, what happens if we shift the so-called precision marker boundary point to here? It will give us the so-called precisions, okay, the number of out of all of the so-called observations here is 3 out of 3 are all 0. So that means our precisions is 100%. But the problem is that it did not pick up all of the zeros. There's instances of positive. It only managed to pick up 3 out of 6. So your recall has dropped when you actually try to increase the precisions. How about the other marker here, this point here? At this point, okay, your precision is 6 out of 8, which is 75%. And your recall is 6 out of 6. Remember, precision is the accuracy of your positive predictions. Okay, how many actual positive is it actually able to pick out all of the so-called predictions that it makes? And whereby your recall is the positive instances that it is able to pick up is 100%. Okay, so as you can see here is that when you try to increase precisions, the recall drop. When you try to increase recall, the actual precision itself dropped. Okay, so let me just give you the actual description here of everything that we've done. Our classifier is designed to pick up 0. All right, so that's what we've done so far. There are 12 observations, the central arrow. Suppose the decision threshold is positioned at the central arrow. We get 4 true positives. We have 4 zeros to the right, 1 false positive, which is actually 7. At this threshold, the precision accuracy is 4 out of 5, which is 80%. Out of the 6 zeros, actual zeros, the classifier only managed to pick up 4. So the recall accuracy is 4 out of 6, which is 67%, which is this one here. The right arrow, we get 3 true positives and no false positive. At this threshold, the precision accuracy is 3 out of 300%. However, out of the 6 zeros, the classifier only pick up 3. The recall accuracy is only 50%. And the left arrow, we get 6 positives, true positives, and 2 false negatives. 6 true positives and 2 negatives. False positives, sorry. At this threshold, the precision accuracy is 6 out of 8, which is 75%. Out of the 6 zeros, the classifier pick up all 6. The recall accuracy is 6 out of 6. I hope that illustrate the so-called trade-off that you have to actually tackle with. This is quite an important concept to actually get hold of. So let's just continue this concept a little bit further. So the classifier that we did earlier is this one here, the stochastic gradient descent. We fit it again. I'm not too sure if you still remember the 1000 index of y is actually a 0. We can actually using the decision function of scikit-learn to figure out what the actual score is. And the score here is negative 5355. Okay, and because our threshold is 0, so that means our decision threshold is 0. So if we actually, let's just say, want to make a predictions, y score greater than the threshold? Okay, if it is greater than the threshold, then it's true. If it's below the threshold, then it's false. And remember, when we actually did our threshold earlier, remember it's a false. The reason it's a false is because we set the threshold as 0. Hence, our prediction was wrong. Our SGD classifier used the threshold of 0. Hence, it actually gives the inaccurate prediction that we've got earlier. Let me just try to find it. Which is just this one here. The prediction was actually false. So it's actually due to that we actually got an inaccurate result. Okay, so what happened if I change my threshold to, let's just say, 4000? It will still be false because obviously this is deeply in the negative territory. So by raising the threshold, it actually decreases the recall. Though the image is actually 0, the high threshold has resulted in the rejection. Okay. So why don't we right now pull out all of the prediction value and then we plot it so that we can actually get a visual of what this looked like. Notice that this is the plot of the actual decision function. Okay, so with the decision score now, we can do something with it. We can actually compute precision and recall for all possible threshold using the precision recall curve and plot it out and have a visual. Because we have all the scores, you see, this is the y-score. We actually stored it in y-scores. We're plotting our actual 0 with the y-scores. That gives us the threshold, the recalls, and also the precisions. I'm going to plot the precision recall versus threshold function and plot it out so that we can actually visualize this. If you look at this, the blue line being the precision, the green line being the recall. And if you have a good look at it, you can see that you can actually make selections. Okay, let me just copy that. So with this chart, you can actually select the threshold value that gives you the best precision recall trade-off for your specific task. Now, this is where understanding the business problem comes in. Some tasks may call for higher precision, meaning the accuracy of positive predictions. This is important. Like designing a classifier that picks up adult contents to protect kids. This will require the classifier to set a very high bar to allow any contents to be consumed by children. Okay, so that's important. So that's really asking for very high precisions. Some tasks may call for high recall, meaning ratio of positive instances that are correctly detected by the classifier. Now, in this case, such as detecting shoplifters, intruders, or surveillance camera or images. Anything that remotely resemble positive instance will be picked up. So it really depends on your business case, your business problem, what you are trying to achieve. The higher precision is necessary if you want to actually allow any contents to be consumed by children. So this is really about picking the right one. So that's why precision is really important, which is the accuracy of positive prediction. Okay, so I hope that is helpful. There are alternative ways to actually tackle the same problem. Some of them meaning you can actually plot the precision against recall to assist with the threshold selection. Just when the drop is substantial, okay, that's where you actually pick it up. And let's just say you choose this part here. Okay, so that's really how you actually use the precisions versus the recall trade-off to actually make your prediction. So let's just say if we want to actually set a high positions. Okay, so if we're aiming for 90% accuracy, how do we do that? So let's just look at the number of observations that we have. We have that many observations. Let's have a look at how many thresholds that we have, slightly different figure. Let's just plot it out and have a look. So if you look at this, let's just say want a precision that is 90%. So we will choose a threshold point, which is our threshold point. And when we actually select the y-score needs to be greater than 21454. Okay, and that gives us the training prediction of 90. So when you calculate the precision score, you see that it's actually 90%. What about the recall score? The recall score then is 92%. So that's really how you actually tackle this problem, rather than leaving the so-called threshold to being default at 0. You can actually dig into the numbers and make the variation yourself. What if I want to set a really, really, really high precision score? Let's just say 99%. Again, you can use the same procedure that we did just now. Okay, now the precision is now 99 rather than 90. Okay, the threshold. So we just make use of that threshold there rather than feed the figure in ourselves manually. And let's just calculate the precision score. Notice that it's now 99%. And I'm pretty sure that you know by now that recall score will suffer. And it did suffer quite substantially, down to 57%. So I hope that has been helpful to illustrate the so-called precision and recall trade-off. Now, before we move on, I'd like you to perform an exercise on calculating a high recall score. Now, try to set that your recall score is greater than 0.9. Okay, so what we've done so far is 99% for high precision and also for 90% as well. Now, under certain circumstances, which we covered earlier, some tasks may call for a high recall, whereby ratio of positive instances that are correctly detected by the classifier. Now, such as the circumstances that require a higher recall, such as detecting shoplifters, intruders on surveillance images, anything that remotely resemble positive instances to be picked up. So this will be the situation that we want to actually have a high recall. Now, I'm gonna ask you to pause the video, and when you come back, I will show you my answer and summarize the lesson. Right, welcome back. This is what I've done. I've set the recall level as greater than 0.9, and it picked up the precision score being 95.8, and recall score as well, if you round it up, pretty much 0.990%. That's really what we're actually aiming to do. So in this lesson, we walk through in depth of the precision as well as the recall trade-off. There are quite a lot of contents to cover. We have covered here, and it's quite a good lesson to actually walk through just to understand the precision and also recall trade-off. And what we're gonna cover in the next video is the receiver operating characteristics. There's another performance measure that's useful, and we will go through that in the next video. I look forward to seeing you then.